Infrastructure capacity buffers are disappearing for years. Operational planning relied on a quiet assumption that rarely appeared in capital plans or risk models. Buffer. Extra capacity in electrical systems, slack in mechanical equipment, time between maintenance cycles, redundancy that allowed teams to absorb variability without escalating decisions. That assumption no longer holds. Across sectors, infrastructure systems are being operated much closer to their practical limits, not because organizations are careless, but because demand density, electrification, and system interdependence have increased faster than physical infrastructure can be upgraded. What once provided resilience is now being consumed just to maintain normal operations. The risk is not sudden collapse, it is the erosion of margin. Capacity was the shock absorber of complex operations. Modern operations are complex by design. Facilities support tightly synchronized production, logistics, digital controls, and energy systems. That complexity historically worked because infrastructure included excess capacity, headroom that absorbed fluctuations without consequence. Electrical systems were sized conservatively. Mechanical systems could handle load variability. Facilities could defer, reroute, or recover without triggering broader disruption. Today, that buffer is shrinking. Electrification of equipment, automation, and data-driven operations increase baseline load even when output remains flat. According to the International Energy Agency, IEA, electricity demand from commercial and industrial users continues to rise globally, driven less by growth alone than by load intensity per facility. In many regions, on-site systems and local distribution infrastructure are struggling to keep pace. At the facility level, this shows up as systems that are technically compliant but operationally constrained. Running near capacity changes the nature of risk. Infrastructure systems do not fail linearly. Operating close to capacity accelerates wear, reduces redundancy, and shortens recovery windows. Electrical components run hotter. Cooling systems lose margin during peak conditions. Backup systems become part of routine operations rather than last resort safeguards. Maintenance schedules tighten. Temporary fixes become permanent. None of this necessarily triggers an incident report. Systems still function. Compliance boxes remain checked, but the cost of deviation increases sharply. What used to be a manageable disruption, a heat wave, a delayed shipment, a piece of equipment operating out of spec, now has fewer places to go. Small issues propagate faster and resolve slower. Operations teams feel this pressure first. Schedules become brittle. Throughput flexibility narrows. Contingency plans rely on systems that no longer have spare capacity to give. Capacity constraints are now strategic constraints. Capacity was once treated as an engineering parameter. Increasingly, it is a strategic limiter. Infrastructure headroom now determines whether organizations can add new equipment or production lines, electrify processes or fleets, support digital workloads on site, expand throughput without destabilizing operations. When buffers disappear, operational decisions become zero-sum. Adding load in one area forces trade-offs elsewhere. Growth initiatives compete directly with reliability. Resilience investments crowd out expansion plans. This is particularly visible in energy-constrained facilities, where electrical capacity becomes the gating factor for nearly every operational decision. But the same pattern appears in cooling, water, compressed air, material handling, and logistics infrastructure. Operations leaders are increasingly forced to say no, not because ideas lack merit, but because systems lack margin. Why legacy planning models are failing. Most capacity planning frameworks were built for stability. They assume predictable load profiles, gradual growth, and limited variability. That assumption no longer reflects reality. Weather volatility, supply chain disruptions, and changing production profiles introduce stress patterns that legacy models struggle to capture. Infrastructure that appears adequate under average conditions may fail under real operating extremes. This explains a growing disconnect. Organizations experience capacity-related constraints even when they technically meet design standards and regulatory requirements. The standards themselves were not designed for today's operating conditions. Capacity looks sufficient on paper. In practice, it is already spoken for. Operating without buffer narrows decision windows. When infrastructure operates near its limits, organizations lose time as well as flexibility. Maintenance becomes harder to schedule without disruption. redundancy becomes theoretical. Recovery from minor failures takes longer and costs more. Upgrades shift from planned investments to urgent interventions. From a financial perspective, this increases volatility. From an operational perspective, it reduces control. Perhaps most importantly, it compresses decision windows. Leaders have less time to evaluate options because systems cannot tolerate delay. Investments become reactive rather than strategic. What operations leaders need to reassess? The disappearance of capacity buffers forces a different set of questions, ones that traditional dashboards rarely answer. Which systems are routinely operating near their practical limits? Where does available capacity exist only in theory? Which growth or resilience plans assume margin that no longer exists? How quickly would small disruptions cascade across interdependent systems? These questions require stress testing infrastructure under realistic scenarios, not idealized averages. They also require cross-functional visibility, facilities, energy, operations, and finance aligned around the same constraints. The strategic implication infrastructure capacity used to be the quiet stabilizer that allowed complexity to function. As that stabilizer erodes, risk becomes harder to contain and decisions become more constrained. Operations leaders are no longer just managing efficiency. They are managing proximity to limits. Recognizing how close systems are to the edge and what trade-offs that proximity forces is now a strategic responsibility. Capacity is no longer just about how much infrastructure exists, it is about how much flexibility remains. You've been listening to Sustainability Soundbites by Environment and Energy Leader. For partnership opportunities, please reach out to our team.